Good afternoon, this is Schweitzer, and this is a little video that's talking about why are some acids stronger than others. We have a few things here, and you'll notice that over the course of your life you've probably heard of a strong acid. That's fine, I guess. A little strong acid. And you also may have also heard of what's called a weak acid. This is a topic that can be delved into with great detail, and so we're going to really, again, keep in mind just barely cover the surface of what this is in this video. It's going to be a real simple video, not going to get too complicated. But you should also understand that there are two other words that might go along with this and be concentrated. And dilute. Students that really don't understand strong or weak might think that a strong acid is just a concentrated strong acid, which is not the case. You can have a concentrated strong acid. If we were to draw a picture of this out right here, okay, you could have a concentrated weak acid. You could have a dilute strong acid. And you could have a dilute weak acid. And you fundamentally should know the difference between each of these. Okay? Now, a strong acid is one that, by definition, is 100% ionized. Now, what does that mean? Well, we have an acid. I'm just going to call it HX. And this acid will react with water to produce H3O plus ions, called the hydronium ion, and we'll have our conjugate anion. So, the concentration, usually in molarity, is equal to moles per liter, is literally describing the amount per area here. So I might have a whole bunch of these HXs. Now let's say I dissolve in concentrate, I'm going to do 10. And dilute, I'm just going to go with, let's go 2 of them. So as I dissolve in my HX, 10 of these guys, okay, and I'm going to put that right here, HX goes to H3O plus X negative, initial amount, stoichiometric shift, and then the end. I would have 10 of these to begin with. Of course, this is our ice table. I'm going to lose all 10 and go down to 0. Goes to completion. I will then gain 10 of these guys, and I will gain 10 of these guys. So I'm going to just do an after picture. Okay. Before picture would have a whole bunch of just HXs. After picture would be H plus 2, 3, 4, 5, 6, 7, 8, 9, and 10. And of course, I would also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, the X negative at this point isn't really affecting the acidity of the thing, of our solution. It's simply the H pluses, and there's lots of them. 100% two products. Now, a dilute, okay, strong acid, still going to have the same reaction, H3O plus X negative. I just initially, stoichiometric ratio ending, only have a lesser number of them. So I'm going to lose all of them, 0, and I'm going to gain 2 of these and gain 2 of those. So it's going to be H plus X minus X minus. So the concentration simply means how many are there. Strength is referring to this situation where 100% conversion to products. All right, so weak. A weak acid means that the same reaction is going to take place. The only difference is that rather than going 100%, we're only going to shift some small percentage. Okay? or I should say some small ratio amount. So if I were to go, let's say, same concentrated amount, so we'll go with initial stoic ratio ending, okay? I have 10 of them. Only difference is that rather than losing all 10, I'm going to only lose, let's say, 2 of them, which means I have 8 of these in the end, and I'm going to gain 2 of these, and I'll gain 2 of these. So I would have HX, HX, still together. Yeah. Still together. And there are 8 of them. 1, still together, 3, 4, 5, 6, 7, and 8. Okay, now, these guys here, HX, okay, this guy is not acidic. Keep that in mind. It is not acidic. It's not acidic until it can undergo this chemical equation or reaction to produce this guy. This is what's acidic. So I'm going to have an H plus and H plus. Keep in mind, just, H plus means H3O plus. Okay? So I have 2 of them there, and I'll have an X negative. Now there's an awfully crowded here, but only thing that's really contributing to the acidity is this guy and this guy. So technically, by my drawings, these 2 would have the same pH because they have the same concentration of H plus ions. This one would have starts out with 2, ends up with 2 here, but this guy starts with many more, but because it's weak, we only get 2 of these H pluses at a time. So they get to the same place by different means. Now, a weak acid that's dilute would be this. Okay, so let's just say we have again, HX goes to H3O plus and X negative. Initial stoic ratio, and 2 of them is our definition at this point. This video is being dilute. The fact that it goes to completion means that I'm going to lose only a small amount. Now, in this case, I only have 2 of them, so I'm going to go minus 1. Leaves 1 behind. And this is 50% converted. That by no means would be a weak acid. A weak acid would be like 5% generally, or 3%. Depends on the concentration. But at this point, I would gain 1 and gain 1. So I'd have HX still there, and I would have an H plus, and I would have an X negative. Again, there we go. So this guy would have this would be the least acidic. Okay, pH probably 6 to 7. Again, weak acid, not a whole lot more. pH 4 to 6. This guy here, pH could be probably going to be probably 3 to 4, and this is going to be most likely 1 to 2. Okay. Either way, I could probably make let's go 5 to 6. Okay, on that guy. All right, so acids, strong, weak. Okay. I will note that there are not very many strong acids. So, with that said, the way we know a strong acid from a weak acid is we basically put to memory the 6 strong acids. Okay, these are the 6 strong acids, and any acid that you come across that's not on this list, of course, we have hydrochloric acid, hydrobromic, hydroiodic, nitric acid, sulfuric acid, and this is perchloric acid. I wrote that one out because it's the least common one that we never heard of. Okay, that is the differences between a strong acid and a weak acid. An example of one that is not strong, okay, would be weak, meaning it's not going to go 100% of products, would be HF, again, AQ, that's hydrofluoric acid, not a strong acid. H3PO4, that's phosphoric acid, pretty common. One of the few edible acids. Or let's say HC2H3O2, this is an organic acid called acetic or vinegar, also not a strong acid. All right. Thank you very much.